I welcome you all. In this video, going to see about building blocks of an algorithm in problem solving and Python programming. Let's see what is building block of an algorithm. Algorithm is defined as effective steps to solve the problem in a finite number of steps, and it can be constructed from some basic building blocks, namely instructions or statements. Then second component is state. Third component is control flow. The fourth component is function. Let's see one by one. Instruction or statement. Statement is a single action in a computer, or we can say it as steps, which solves a particular problem. In a computer, the statements might include some of the actions. Input data information that is given to the program. Then process data. It performs operation on a given input. The third one is output data, that is the processed result. Based on this, most algorithms have the basic parts or statements. They are description of the problem, then setup, parameters, execution, conclusion. Description of the problem, that is description of the problem we are going to solve. For example, to find the sum of two numbers. So this is the description of the problem. The next statement is setup. Two numbers required for addition and one variable for storing the result. So this is the setup statement of the algorithm. Next one is parameter. In order to perform the task, we need some parameter to complete the task. For example, to find the sum of two numbers. So we need to read two numbers. So that is the parameter of the statements. The output statement in the algorithm is the conclusion statement. Next statement is state. State is defined as the condition of algorithm at a moment in a time. That is transition from one process to another process under specific condition within a time. That is called state. The algorithm can be any of the following states. The start state represents the starting of the program, and the input state represents the process of reading the input from the user. The third one, process state, it represents the process done in the program. For example, arithmetic operation, addition, subtraction, etc. In the output state, the output is displayed on the screen. The fifth state, stop state, it represents the ending of the program. In this algorithm, different statements are used in different states. The third component is control flow. The process of executing the individual statements in a given order is called control flow. It represents the order of statement execution and direction of flow of programs. The control can be executed in three ways. One is sequential control flow. The second way is selection control flow. Third way is iteration control flow. Let's see one by one. Sequential control flow. All the instructions are executed one after another is called sequence execution. The steps of an algorithm are carried out in a sequential manner. This diagram shows that all the statements in the algorithm are executed one by one. This flowchart represents the statements all are executed in a sequential order. Next, selection control flow. A selection statement causes the program control to be transferred to a specific part of the program based upon the condition. If the conditional test is true, one part of the program will be executed. Otherwise, it will execute the other part of the program. Only one of the alternative steps is executed based on the condition. The diagram shows that only one input is received by the conditional statement. Here the condition is performed. It checks the condition. Then based on the condition, it will execute the result. If the condition is satisfied, then it will execute the statement 1. If the condition is not satisfied, means it will execute the statement 2. Finally, it will exit the loop. In this example, one condition is given, that is A is greater than B. If this condition is satisfied, then the message A is big will be displayed. If this message is not satisfied, then the message B is big will be displayed. Next, repetition control flow. In some programs, certain set of statements are executed again and again based upon conditional test, that is executed more than one time. One or more steps are performed repeatedly. This type of execution is called looping or iteration. The last component is function. Function is a subprogram which consists of block of code, that is set of instructions that performs a particular task. For a complex problem, the problem is being divided into smaller and simpler tasks during the algorithm design. When using functions in a program, we have certain benefits. They are reduction in line of code, code reuse, better readability, information hiding, easy to debug and test, then improved maintainability. So these are the benefits of using functions. This is the example algorithm for addition of two numbers using function. In the main function, simply call the function add, and in the subfunction, the variables a and b are defined. And here the actual process is happen in the subfunction add. Then finally it will return the value. Thank you.